Hello everyone! A few weeks ago I was selected as a beta tester for a new single-board computer named Guitar. This board is being developed by a Chinese company called LeMaker with the aim of becoming a cheaper but more powerful alternative to the Raspberry Pi. However, this board stands out from similar projects because it's not a clone of the Raspberry Pi. At first sight, the Guitar is slightly bigger than other single-board computers, but you can take off the central module which houses its main components. This might come in handy for projects where space is limited. The rest of the board features 40 GPIO pins, a couple of connectors to plug external modules, and some ports. Unlike other boards, this one comes with a pre-installed operating system based on Linux. In fact, aside from a bit of lag, it looks and feels like a desktop version of Ubuntu. This board features a built-in Wi-Fi and Bluetooth module, and it actually works out of the box. My wireless network was detected automatically, and I was able to connect to it without any additional configuration. The apps are the same that you will find after installing Ubuntu for the first time. Some games, a couple of utilities, and even a BitTorrent client. Firefox is the default browser and it works perfectly. I'm going to open a couple of websites that haven't been visited before using this board. This means that there are no cached files that the browser might use to speed up the loading time. As you can see, they loaded very quickly and without any issues. According to the developer's website, this board is capable of playing 4K video files. This is a very bold claim, and I will try to verify if it's possible to do so without messing up with config files or overclocking. Fortunately, one of the pre-installed apps is Kodi, a media center. However, this board has very limited free space, so I will have to use a USB flash drive to load the test files. As you can see, it was detected and mounted within a few seconds. In order to test the video playback, I will use the OpenMovie Syntel in 3 different resolutions. The 720p version runs smoothly with a crisp image and without any sound synchronization issues. The same can be said about the 1080p version. No issues so far. When I try to play the 4K version, things start to get very slow. Both video and audio are sluggish, and for a moment I thought that the app would crash. However, after waiting for 10 minutes, that didn't happen. In fact, I was able to close the program and get back to the desktop. After that, the slowdown issues stopped. And now it's time to get into more technical issues. According to the disk utility, this board features an 8GB solid-state disk. Unfortunately, a big part of it isn't partitioned by default. This seems to be an issue that will be fixed in the future, but for now, it's possible to use this free space with the help of gpart. After using the benchmark tool, these are the results I obtained. I must say, they are not too bad for a single board computer. This is how Ubuntu's resource monitor looks when this board is idle, with only the default processes running. Now I will use a couple of browser-based benchmark tools. The first one is Octane. Basically, it will test how good is this board at executing web applications. Some of them can be quite demanding and even crash some mobile devices. As you can see, the guitar managed to pass the test without crashing or freezing, which is a good sign. In this case, a bigger score means better performance. Next is the SunSpider benchmark. It measures how fast can a system execute a series of tests based on the JavaScript language. Finally, I downloaded Sysbench, a popular multi-platform benchmarking tool. In order to test the processor speed, I will ask it to calculate all the prime numbers up to 20,000 and see how long it takes to complete the task. This first test took quite some time because it's only using one processor core. Now I will repeat the test, but this time I will ask Sysbench to use all the available cores. As you can see, the execution time has been greatly reduced. The final test measures the memory speed and it was completed very quickly. In summary, these are the numbers I got after all the tests. For now, I don't think it should be fair to compare these results with other boards as the guitar is still on an early development phase and running an operating system that isn't optimized for it. Anyways, these numbers look very good. On the bright side, we have an onboard Wi-Fi and Bluetooth module that works out of the box. A USB 3 port. So far, none of the other commercially available single-board computers offer support for this standard. Some promising hardware specs. The price is estimated to be around $25. However, not everything are good news on this board. Right now, the operating system is not optimized. There is a lack of ways to control the GPIO pins. At this moment, you can use them with the aid of the Banana Pro library, but it's only a limited solution. 4K video support doesn't work. It should be noted that these issues can be solved with some work from the development team. This board looks truly promising, and I feel that the makers community could benefit from another alternative to a Raspberry Pi. Last week I got an email with a download link for a more optimized operative system, and the development team is working very hard to make a port of the graphical programming language Scratch. So, this means that there could be some good news for this board in the near future.